Daniel Lenton, founder, Unify.
Okay, hello everybody. Very nice to be here. My name is Daniel Lenton. I'm the founder of Unify, where we are striving to give the best LLM on every prompt, basically. So what does that mean exactly? Well, first to set the context a little bit. This hasn't loaded correctly. I'll skip past this slide, actually. Basically, when you're deploying your LLMs, you have these different factors to care about. So you might care about getting high throughput, or low latency, or low cost, or high quality. And of course, ideally, you would get all of these things in one. You would basically have a system that is perfect at all of these. But unfortunately, you cannot have your cake and eat it. When you want to optimize these things, optimizing for one inevitably brings the performance down on the others. And then you end up playing around with all the different models, playing around with all of the different providers, and just trying to tweak things until you get your perfect balance of competing for these three factors, basically. So high level, what we're doing at Unify, we've built a dynamic router that basically enables you to not just receive whatever the providers and the models give you in terms of their specific data point for quality, speed, and cost, but basically you can move these yourself. You can imagine that you can say, okay, well, I want to have this much quality, this much speed, I want it to be about this expensive, and you can directly do that and then get a system that matches your preferences for whatever it is you want, basically. And this is how to think about it. The way that we do this is that the prompt comes in, and then we know which model and which provider to send it to such that we can reach your target quality, speed, and cost profile, basically. This is the idea. So this is what's shown in this kind of simple graphic here. The prompt comes in, and we send it to whichever is most appropriate. So, send it maybe to Cohere or Mistral, for example. And this basically enables you to control your data point in terms of performance in this three-dimensional space of cost, quality, and control. But rather than giving just lots of nice graphics, it'd be great to actually go through and see what this looks like in practice, basically. So we have a simple walkthrough here, where basically what you do is you do try now, and you're taken straight away to this chat interface where you can have the router directly alongside GPT-4. So the question in this case is, what are some of the potential benefits of dynamically routing to different LLMs? We see that GPT-4 and the router are getting started. The router's already off to the races, already finished, in fact, so much quicker than GPT-4. We can see here at the top that we basically have the quality, cost, time to first token, and inter-token latency. So this is how much it cares about these competing factors, basically. We were able to get 174 tokens per second versus GPT-4, what is still not finished, actually not completed at all. We were able to get a similar time to first token and much cheaper, about 100 times cheaper than GPT-4 in this case. So e to the minus 4 versus e to the minus 2. In terms of the response quality as well, very similar. And also on the speed, it's about 8 times faster. So tokens per second, it was about 8 times faster than it was for the router. In terms of the quality, again, similar points, cost efficiency, load balancing. Slightly ironic having GPT-4 talk about cost efficiency, given it was 100 times more expensive and slower as well. So this is just like, as a high level, what the router can do. Basically, this router will use a mixture of Mixtral 8x22b, Llama 3, and Mixtral 8x7b. Well, that's all well and good, but actually, that's just one random configuration of the router. You really want to be able to control this much more flexibly. What we have are these graphs where you can basically see all of the different models and all the different providers in one space. So we have the cost per million tokens on the x-axis, the score on the y-axis using GPT-4 as a judge, and all of these data points are unique model provider pairings, with the stars being the router configurations. We can select the benchmark this is all done on. Right now it's OpenHermes, but we can use any of them, whether it's a programming data set or a general knowledge data set. In this case, we'll be looking at MT-Bench, which is some general generative stuff. We can change the x-axis to be time to first token or inter-token latency. We can see all kinds of data we want. For now, we'll stick with cost. And then you can just choose which of these look the best. So first of all, we have these horizontal lines, which are models. So these are all Llama 2. So the same quality, but with different costs. These are all Code Llama, for example. These are all Mixtral, for example. So these horizontal lines where the model is the same, but the costs change. But really, the router configurations are the ones where we can have more control. So this top left one looks pretty good. Very, very cheap, very high performing, much better than most of these point solutions. So that seems pretty sensible. But what about the speed? Okay, that's not great. It's okay, but the time to first token could be better. What about the inter-token latency? Again, not great, could be better. Maybe let's try this one as well. This one could be a slightly better version. What about the time to first token? Yep, that looks better as well. What about the cost? Okay, a bit more expensive, about twice as much money compared to the previous one, 67 cents versus 37 cents. But basically we see these, okay, so we have these two router configurations. We can either double the price, but also half the speed, or double the speed and half the price. And we can kind of see how we can trade these things off and reason about that in a very intuitive, visual way. But now let's actually play with these. So let's kind of see, actually send some prompts to this, see how they perform out in the wild. So what we can do is just compare these again to GPT-4 as a reference, and then go in and chat with it directly in the app, basically. So then, yeah, we can type a prompt. I've forgotten what I did on the video. I guess we'll see what the question is. Oh yeah, what are some of the benefits of having multiple LLM providers versus having a single provider? Again, slightly meta question for OpenAI to tell us why it's a good thing. Yeah, and then again, as before, we get the routers are done in like no time. GPT-4 is still going for a very long time. Again, I'm not sure you can see at the back, so sorry if the text is a bit small. But yeah, we have like 160 tokens per second, so really fast, 60 tokens per second on the middle one. Actually, in this case, the cheap option that optimizes mainly for cost was also faster. So for this prompt, the kind of cheap router configuration is probably the best, but both of them were, by and large, much better than GPT-4, which is about 100 times more expensive than the leftmost, about 10 times more expensive than the middle one, and about half the speed or 4 times slower than the best option. So this is quite technical. I also talk quite fast. For this, I just thought rather than like talk in the abstract, I'd give you a bit of a sense of what the router can do in a hopefully semi-intuitive way. This actually video will keep going. So, okay, no, it stopped already. Perfect. So the next one was just, yeah, thank you very much for listening, everybody. Thank you.